12th Maths, Chapter 5, Exercise 5.7, question number 16. If e power y into x plus 1 is equal to 1, show that d squared y by dx squared is equal to dy by dx the whole squared. So, given statement is e power y into x plus 1 is equal to 1. So, we need to show d squared y by dx squared. Second derivative is square of the first derivative, dy by dx, the whole square. So, differentiate with respect to x. With respect to x. So, you can apply the UV method. Because it is an implicit function, we cannot separate y alone. So, apply UV method. Keep u as constant, that is e power y constant. Differentiate this x with respect to x. So, you will get 1. Then 1 is constant 0 plus x plus 1 b. Then differentiate e power y into dy by dx is equal to right side term is constant. So, you will get 0. So, see here this x plus 1 and e power y. See, I have this is equal to 1. They given this is equal to 1 in the problem. So, I replace this as 1 into dy by dx is equal to 0. Just I mark this as 1 from 1. This is the given problem actually. So, dy by dx equal to, take this e power y right side. So, it is minus e power y. Now, we need second derivative. Differentiate again with respect to x. So, d square y by dx squared is equal to minus e power y, you will get e power y, and then with respect to x, so differentiate y with respect to x, so dy by dx. So, minus e power y. Let me substitute this dy by dx is here, I got minus e power y. So, minus e power y from 2. So, minus into minus plus e power 2y. So, that is, so just I read, so see, you know, I need not write this one. Let me rub it off here. So, what I do? Minus e power y the whole squared. What is minus e power y? That is our dy by dx. So, dy by dx the whole squared. So, left side d squared y by dx squared equal to, we proved the answer, dy by dx the whole squared, proved. Take the 17th sum. If y is equal to tan inverse x the whole squared, show that, this is the statement, x square plus 1 the whole squared, y2 plus 2x into x square plus 1 into y1 is equal to 2. So, let me take the given statement, y equal to tan inverse x the whole squared. We need to find second derivative. y2 stands for second derivative, d squared y by dx squared. y1 stands for dy by dx. So, y1 is dy by dx, y2 is d square y by dx squared. So, let me use the same. Differentiate with respect to x. So, dy by dx, I write y1. So, degree you have 2 into tan inverse x. Derivative of tan inverse x is 1 by 1 plus x squared. Take this 1 plus x squared to the left side. 1 plus x squared into y1 equal to 2 tan inverse x. We need to find y2 also. Differentiate again with respect to x. Again with respect to x. Apply UV method. So keep 1 plus x squared constant. Differentiate y1. So dy by dx, if we differentiate again, you will get d squared y by dx squared. That is your y2. Plus y1. Constant 1 is constant 0, x squared 2x is equal to right side tan inverse x. So 1 by 1 plus x squared. So we have to do the simplification. So right side you have the fraction. What I do, I multiply all the term by 1 plus x squared, the denominator term. So if I multiply this 1 plus x squared, the whole squared y2 plus 2x y1, and then multiply this 1 plus x squared is equal to this 1 plus x squared into 1 plus x squared cancel, you will get 2. So this is the answer. You just see the proving part. X square plus 1 the whole square y2 plus 2x y1 x square plus 1 equal to 0. So with that we prove the answer. If y equal to 3 cos log x plus 4 sin log x, show that x squared y2 plus x y1 plus y equal to 0. As I said, y1 stands for dy by dx. y2 stands for second derivative, d squared y by dx squared. So differentiate with respect to x. So y1, instead of writing here, because they are getting the term y1 y2, so I write y1 equal to 3 constant, differentiate cos, you will get minus sin log x. So just we differentiate cos only, that is minus sin, and then differentiate log x, that is 1 by x over plus 4 sin x cos log x. Differentiate log x, you will get 1 by x. Next is, you can take 1 by x as common here. So y1 is equal, take 1 by x common, minus 3 sin log x plus 4 cos log x. 4 cos log x. But here we cannot replace because this is 3 cos log x 4. So what I do, again I differentiate. You take this x to the left side, x y1 equal to minus 3 sin log x plus 4 cos log x. Now differentiate again with respect to x. With respect to x. So you have to apply UV method here, x and y1, two variables. Keep x constant, differentiate y1. So you will get y2. Derivative of dy by dx is d squared y by dx square, y2. Keep y1 constant, differentiate x, you will get 1. Now differentiate the right side, minus 3 sin, so cos log x. Then differentiate log x, you will get 1 by x plus 4 constant, differentiate cos, you will get minus sin. So minus sin log x into 1 by x. Next step, what you do? You take minus common, both the terms have minus, 1 by x. So 3 3 cos log x plus 4 sin log x. 4 sin log x. So, you take this x to the left side, you will get x into xy2 plus y1 is equal to minus, so what about this term? This is y, so minus y. So x squared y2 plus xy1, bring this y to the left side, plus y is equal to 0. So this is what you have to prove. Proved. See, next sum, same model. I am going to do example sum. Example 38. Sum is if y is equal to sine inverse x, show that this statement. Let me take the given one. Y is equal to sine inverse x. I have to find the second derivative. So, differentiate with respect to x. So, dy by dx. Here they use dy by dx. So, dy by dx equal to derivative of sine inverse x is formula 1 by root of 1 minus x squared. This is the formula. So, 1 by root of 1 minus x squared. So just I write this as y1 is equal to 1 by root of 1 minus x squared. Take this 1 minus x squared to the left side. 1 minus x squared y1 equal to 1. Squaring on both sides. Squaring on both sides. So the square root will goes of 1 minus x squared into y1 is equal to 1. Differentiate again with respect to x. So UV method. So 1 minus x squared. So differentiate y1, you will get y2. Derivative of first one y1 is y2. Then keep y1 constant. 1 is 0, x squared minus 2x is equal to 0. So 1 minus x squared into y2 minus, small mistake I have done here. See, this one is actually squaring on both sides. So root is 1 minus x squared. Y1 you will get y1 square. Y1 square. So now you differentiate again with respect to x. So keep 1 minus x squared constant. Y1 squared 2y1. Derivative of y1 is y2. 2y1 and then we differentiate y1. So you are getting y2 plus y1 square, differentiate this 1 minus x squared, 1 is 0, so minus 2x is equal to 0. So here 2 is common in both the terms and also y1 is common, divide by 2y1. So you will get 1 minus x squared y2, this minus, we have taken 2 outside, 1 y1 outside, so 2y1 is equal to, xy1 is equal to 0. So 1 minus x squared y2 minus xy1 equal to 0. This is the answer. I hope you understood the same model. So you practice the same model. Thank you.